right, guys, welcome back to the second part of 5.3, and today we're going to go a little more involved with the unit circle. And, I really encourage you guys to get used to the unit circle or, those triangles that we looked at in 5.2 to find the values for these trig functions. Because I know you can just put them in your calculator, you can just look it up, but, especially if you take any math classes in college, every single math class I took, you were not allowed to use a calculator. The only math class I ever took in my entire career at college was a stats class. I took Calc 1, 2, 3, differential equations 1, differential equations 2, linear algebra, advanced calculus, modern algebra, all these things. I was not allowed to have a calculator during a single test on any of them. So you do have to get used to using these trig functions, especially if you are thinking of even just maybe continuing math in the future. So anyways, example 3 says use the unit circle to find the values of the 6 trigonometric functions for a 135-degree angle. And almost with any problem in math, if I can draw something, that is immediately what I'm going to do because it's going to help me out. So I know that 135 degrees, if we have our base angle here, 135 degrees is going to be somewhere in there, right? Not 180, but greater than 90. And so I'm just going to stick it there. But I'm going to find its reference angle. So if I do 180 degrees minus 135 degrees, that's going to get me 45 degrees. So that means that this little angle here is 45 degrees. Now, what does that tell me, right? So if I have a unit circle going around here, then this point I know is 45 degrees, right? I can use 45 degrees, and I know that cosine and sine 45 degrees, but I know that this point is going to be square root of 2 all over 2 and square root of 2 over 2, right? But not quite, right? The x is negative because we are in that second quadrant. So that's what the unit circle helps you to identify, is that you're negative there. So that's where it intersects the unit circle. And so now we're going to use that to identify all. So I'm going to rewrite it over here. We have negative square root 2 over 2 and positive square root 2 over 2. And then we can think of this as our x and y, right? And if we remember, our sine of theta, if this was theta, our sine of theta is just y, right? So square root of 2 over 2. Cosine of theta is x, so negative square root of 2 over 2. Tangent of theta, tangent of theta is going to be what? Y over x, or sine over cosine. So what is square root of 2 over 2 divided by negative square root of 2 over 2, right? That's dividing by a fraction is multiplying by the reciprocal, right? So this would actually be multiplying by negative 2 over square root of 2. So that's actually going to be negative 1, right? And now we just do the reciprocal, right? So cosecant goes with sine, So the reciprocal is going to be 2 square roots of 2 over 2. I've just already rationalized in my head, right? So it would be 2 over the square root of 2, right? And then to rationalize, we'd have to times square root of 2 times square root of 2, right? And so then this turns into 2, and we have 2 square roots of 2. So that's where that's coming from when I'm doing that fast in my head. And then for cosine, secant theta is, we're flipping that one too, and this one's just going to be negative 2 square roots of 2 all over 2. And then tangent theta, or cotangent theta, the reciprocal is still just going to be -1, right? The reciprocal of -1 over 1 is just 1 over -1, which is just -1. All right. Now, for example 4, it says find the values of the 6 trigonometric functions for angle theta in standard position if a point with coordinates 5, -12 lies on its terminal side. So I'm just going to kind of like forget about that. And I'm just going to say, well, let me draw a graph. And coordinates 5, -12, right? That's going to be like 5, -12, somewhere around there, right? I'm just drawing a picture. 5, -12. And from there, I can make a triangle, right? And I know that this x distance is 5, and I know that this is -12. And so we can already guess, and then we can find out the length of our radius here. Our radius, right, if we were to draw a circle. And if you remember from geometry, this is a Pythagorean triple. It'll be 5, 12, and 13. Now, our radius, which is this line here, will always be positive. And so now that we have this triangle information, we can use the, because 5 is our x, -12 is our y, and if this is our theta, we can now find sine, cosine, and tangent of all of these values. Sine is y, cosine is x, so this one's a little different, right? Because our radius is 13, right? It's not 1. We're not on a unit circle. But now that we found that, we can use this. So sine is opposite, which is -12, over hypotenuse, which is now 13, right? So we've made a right triangle right there. And that's what I use more than thinking of the unit circle. So now cosine of theta is going to be adjacent, which is 5, +5, and over hypotenuse is 13. And then tangent of theta is going to be adjacent, which is 5, or opposite over adjacent, sorry, TOA. So -12 over adjacent, which is 5. And then from there, we can write the reciprocal ones. So cosecant of theta, we're just going to flip them, -13 over 12. Secant of theta, we're going to flip that one. It's going to be 13 over 5. And cotangent is going to be -5 over 12. All right, so not so bad. And now, suppose theta is an angle in standard position whose terminal side lies in quadrant 3. Again, a lot of words here, and I think what's going to help is if I just draw myself a picture. So we know we're in quadrant 3, which is this lower left one here. whose terminal side of quadrant 3, if sine of theta equals -4/5. Okay, well let me just pretend I have an angle here, right? So I have some angle in quadrant 3. I don't know what it is, it's not telling me, but it is telling me that this is going to be my reference angle here. And so it's telling me that sine of that angle is going to be -4/5. Well, remember, sine of theta SOHCAHTOA is opposite over hypotenuse. So 4 is up. I can make a triangle here, right triangle, and 4 is opposite of that angle, right? So we have 4, or we have 4 this way, and then over hypotenuse is 5. Oh, but being in quadrant 3, this should be a -4, right? And then again, Pythagorean and triple, that'll be a 3, 4, 5, but we're left on the x-axis, so that should be -3. And now that I have all of those things, I can write the rest. So it's already given us sine equals -4/5, right? So opposite over hypotenuse, that makes sense. Now we just need to do the rest. So cosine of theta, tangent of theta, and then it's given us sine, right? I'll rewrite it here just in case. Sine of theta equals -4/5. Cosine of theta is going to be adjacent, which is -3, and then over 5 over hypotenuse. Tangent, opposite over adjacent. Opposite is -4, and adjacent is -3. So the negatives are going to cancel. It's going to be +4/3. And now we can run through the reciprocals again, right? So the reciprocal of sine is cosecant, which is going to be -5/4. So just flip them. The reciprocal of cosine is going to be secant. Just flip them. We're going to get -5/3. And the reciprocal of tangent is cotangent, which is just going to get us 3/4. That's 3. And that is going to wrap up 5.3.